yesterday, you were with Coach Perez, and you went over two lessons, and the majority of you did really good. So you got two easy grades, which was great. You did the functions and evaluate functions, but you weren't here yesterday. You did those. Just keep in mind, if you did not get the grades you wanted, yesterday, you can redo it up to an 80. And there's probably, maybe 4 or 5 of you, maybe not even that, 4 or 5 of you that might want to redo your grades. So let's do it, but not everybody else got hundreds on both of them, so that was good. Which is why I left that one, because it was an easy lesson. So today we're going to follow the same kind of thing. And remember, those of you that were absent yesterday, be sure to go back and redo it, otherwise that would be 0 for you. Be sure to go back and do it. Remember, you got 2 days to redo it. And you still get that same option after the 2 days. You get a 100. You can get it done within those 2 days. But anyway, moving right along to today. So you were working on functions and evaluating functions yesterday. You talked about relations and functions. You talked about everybody's Chromebooks need to be put up. All phones need to be put up. We talked about, we talked about relations, functions. Can you tell me the difference between a relation and a function? You're on the right course. They're both ordered pairs, right? Okay, so they're both ordered pairs. You want to add to it then?
A relation is just an ordered pair.
Okay.
Function is an ordered pair where every x value is on one line.
Okay, that's the key distinction there. A relation is just a set of ordered pairs. Doesn't matter anything about whether things are repeated or not. And a function is also a set of ordered pairs that has one big distinction, and just what Sam said, there's a one-to-one, there's exactly one x value that goes with every y value. Or in layman's terms, no x's are repeated. The x's can't be repeated. So there were different types of ways that they asked you on that, we'll do that. The different types of ways they asked you to decide if it was a relation or a function. They gave you a set of ordered pairs. And if the x's were repeated, which in that case the x's aren't repeated, so it was a function, or it could have looked like a mapping. Whoops, that's not what I meant to do. A mapping where they do the circles. Bless you. Oh, we do that in a different color. So we did. Would that be a function or not? Why is that not a function? Because there's two. What was it, Christian? The one has 2 things coming out from it, right? The one has a 4 and the one has a 5. If we wrote that out as a set of ordered pairs, gentlemen, it'd be really nice if y'all pay attention. 1, 5, 2, 5, and 3, 6. So if you wrote that out as ordered pairs, that one is repeated. But in the other way you did decide if it was a function or not was by a graph, and you did something called the what? How do you tell if it was a function by a graph? The vertical line test. If you drew vertical lines on that, would it hit that red curve more than once? Does any green line hit the red more than once? And no, it doesn't. So that one is a function. And then you went into the evaluating the function, where you got into the notation, and they talked about f of x, and it's read f of x, and that's the same thing as y. You can replace function notation with y anywhere. It doesn't matter what the letter on the outside is, whether it's f or the number inside the parentheses is always gonna go in for the x. So if we said y equals 2x plus 3, is that the same thing as f of x equals 2x plus 3? Yeah, it's the same thing. You can just interchange the y with the f of x. And then they got into, okay, let's put in some numbers in there. So f of 4, you would have just said, oh, that's 2 times 4 plus 3, right? You just plug in that number in there. So all of that's what you did yesterday. Again, 2 really easy lessons. So today we're going to get into interpreting functions, which you have done this before. How many times have we done word problems where they give you the word problem and you have to write the equation? We did it a bunch last week. We've done it before. But they're going to bring it in context with the, okay. They're going to bring it in context with more word problems, but they're talking about when it says in context, it just means it's a real world situation. It's just a word problem is all it is. We've done linear functions, we've done quadratic functions, and we've done exponential functions. So in this example, Pete's Pizzeria charges $2.50 delivery fee for all deliveries and $5.99 for each medium pizza. What's the key word right here? Each. Each means what? The rate, which is also the slope, okay? That's the rate. That's where that $5.99 is coming in right there. That $2.50, what do we call it? Whoops, I can highlight that. What do we call this? The initial or the starting point. So what they're asking, I mean, they go through all of this and they say the following equation represents the total cost y. So y is the total cost. It's important to make sure you know what the variables mean. And a customer who orders X medium pizzas. So y is the cost, X is the number of pizzas they ordered, right? What does the y-intercept mean? Who can tell me what that well, first of all, you have to know what the y-intercept was. And hopefully by now y'all know this is the y-intercept, this is the b, and that y equals mx plus b. This is our starting point. So we did this a lot when we started linear equations. And I said, remember those questions I wrote on your test? And I said, you're going to have to interpret these in context. You're going to have to tell me in a sentence what $5.99 means, what $2.50 means. So, all right, Kel, I saw your hand raised. What does the y-intercept represent? Give us a sentence.
For every pizza bought with a
For every pizza bought?
No,
Well, you got that one word. It's not for every pizza. For every order.
Yes,
For every order. There you go. Alright, so what they've got down here is the y-intercept represents the amount of the delivery fee. And you know that. That's the amount that it costs. It tells you right there. $2.50 delivery fee. It tells you right there in there. So, I mean, that's an easy one. That's a gimme type question. This one, they're going to call this an algebraic representation. So in our standards, you have to know how to interpret things going from the word, they call this the word representation, to the algebraic representation, to the graphical representation. So it says the linear model shows below. Why is it linear? Oh, it's a line. It's a straight line. The linear model below shows the population of a town X years, here's T, after 1980. I promise you're going to find something like this on your test. And they're going to put that after in there to trick you, so just be careful. So X years, the population of the town. So what's happened to the population? Is it increasing or decreasing? It's decreasing because that's a negative slope. So according to the model, what was the population in 1980? According to the model, what was the population in 1980? So what point represents 1980? 0, right? Did they show you that point? They didn't show you where that crossed, did they? Could we find where it crossed? Did they give us 2 points on here? Could we find our slope? 2 ways we could find our slope. How can we do that? Well, 3 ways actually. We could use the graph and we could count up and Over, alright, so if we go up, we gotta be careful here, how much are these going up by? 2,500? It's from 0 to, it's going up 1,500, right? So if it goes up 1,500, that's 3,000, right? So 3,000 over, now how much are these counting by? From 12 to, no, each line's not worth 4, each line's worth 2. So if I go up 3,000 and over 2, 4, 6, so if I go this point, up 3,000, or up 2 times, up to, hello? Hey. Okay, alright, we're doing good. Alright, see ya, bye. Alright, so we're going up 2 times and over, what was it, 3 times? Is that it? Up 2, over 3. Now you gotta think about it right here. If I go up 2, up 1, up 2, that's at 12,000. So that would be 13,500, right? That would, if I gotta go up to 13,500, 15,000, 16,500. See what I'm doing? We could figure out a graph here. Let me see if of course somebody's not looking, but that's okay. Let me see if we can do a split screen here. I'll do it this way. Alright, so if we have, let's see, we've got a graph, and we were at what, 12,000 right here? And that was Tuesday, what was our other one? Okay, there it is. Alright, so if we're at 10, there's 13,500, there's 15, there's, so make sure I'm writing this, 16,500 and 18, did I add those correctly? And we were at 10,500, which is right here. So 10,500. See what I'm doing. Alright, so there's 10,500. So we said we're going up 2, right? Up 2, right 3. 1, 2, 3. So there's that point. And then up 2, right 3, but right 3 is over here, isn't it? So could we come up with some kind of guesstimate at what it was? Somewhere between 15,000 and 15,500? Something right in there. So that would be one way we could use the graph. What's another way? How can I use my calculator to help me out? Did they give me 2 points? What do I do with the calculator when I'm given 2? Put them in there. Could I put 10 and 16 in L1 and 10,500 and 7,500 in L2? Yeah, alright, so let's do that. I have no idea what's in this calculator, so let's see. So we'll go stat, edit. Again, of course, some of you aren't paying attention, and that's why when you try doing these, you don't know what you're doing. Then you go home and, decide you're going to tell mom and dad you don't know what you're doing, but you never say, oh, I didn't do what I was supposed to be doing either. So we're going to put in 10 and 16 in L1. So 10 and 16 in L1. This should be old hat by now. We've done this too many times. So everybody should be doing this. 10 and 16. Then we're going to put in 10,500, 7,500. It doesn't matter which order you put them in, as long as you keep them with the same thing. So 10,500, 7,500. So Nikki should probably put these in just like we are. If I'm typing buttons, you should be typing buttons on your calculator. I'm pretty sure I know what I'm doing, and the reason is because I've done it over and over and over so many times. This is why I want you to do it over and over and over so many times. So I've got my points in here. How do I get my line? How do we find that linear equation? What do we do next? Stat, calc. So we're doing stat, calc, which one are we doing? 4. We're doing a linear regression. So make sure you're on L1 and L2 when we are. I don't really care where I'm going to store it. So I'm going to graph it. I'm just going to calculate it. Does it give me my y-intercept right here? Yeah, it gave me B, 15,500. How hard was that? It's just a matter of putting those points in. That's all it is. So if we come back over here, 16,500, they may have used, they used the slope equation to find the slope. And then they used point slope, and they plugged in their slope, and they plugged in one of their points, and they went through all of that. Why would you want to go through all of that when all you gotta do is put in L1 and L2 and calculate that regression equation? Much easier, but you gotta know when to use that option. You gotta know when to do that. Let's say this is one that you didn't have your calculator on, and you couldn't put it in the equation. Was it so hard to draw something out and come up with a pretty good guess as to where it was? No, I mean, mine's a crappy looking graph. You're gonna have graph paper, even though you're doing this on the computer, you're still gonna have graph paper you can use to draw. So don't just, don't give up, don't guess on it. Alright, so there, we got the population 15,500, so we're good. Alright, now, next one, let me put this one up, okay. Table below shows the distance a turtle walks over time. Is the rate of change in distance with respect to time constant, and what is the value of the rate of change? Right, so the first question, you're probably not going to have this question on your test. Probably not going to ask you that one, but it's not a hard. They're asking, did he walk the same speed every minute? Well, how much are you going up from 6 to 12? 6, from 12 to 18? 6, from 18 to 24, 6, alright, 1 to 2, 2 to 3, 3 to 4, alright, so 6 over 1, 6 over 1, remember when we did the first differences, and we subtracted those numbers, were all those the same? Yeah, so we know his rate, we just actually did it in our heads, what's 6 divided by 1? 6, but could we put that in L1, let's go through and do that, put those in L1, 1, 2, 3, 4, put your distance in L2, yes ma'am. Yes, okay. Put your distance in L2, so 1, 2, 3, 4, 6, 12, 18, 24. So 1, 2, 3, 4. Let me clear my list out. Remember, when you clear your list, don't hit what? Delete. Don't hit delete. Alright, so 1, 2, 3, 4. And then L2 was 6, 12, 18, and 24. There we go. Alright, we're calculating that regression line, and what are we looking for though? What is it asking us? The value of the rate of change. What's another way of saying that? The slope. That's what they're asking. What's the slope? So what's the slope? 6. We got it. 6 right there. Alright, so that would be enough. Alright, so when they go through and show you all this, see what they did? 12 minus 6, 18 minus 12. They did the same thing we did. We just did it in our head real quick. Alright, now, exponential functions. So we've talked about linear. We're going to go through exponential. So Anita won $500 at a cooking competition. Well, $500. There's her starting point. So she decides to open an interest-bearing savings account. She's going to put it in the savings account, going to put it in the bank, compounding continuously at a fixed annual interest rate of 3.5. Notice, did they put 3.5 in here? No, they put 0.035. They took that decimal and moved it 2 places left. The function below represents the balance of Anita's account, a to the x after x months. So what does the y-intercept represent? What's her starting point? What was her starting point? $500. What does that represent? How much money she put in the bank? Her initial deposit. What's her starting point? That's all that one asks. Alright, here's another one. A community launches a waste disposal plan to reduce the amount of waste each person throws out by 2%. They're reducing it by 2%, right? Where did that 0.98 come from? 1 minus, not 2, but 1 minus 0.02. Remember, they're reducing it. So they're reducing, so it's 1 minus 0.02. So that's where that came from. All right, this year each person threw out an average of 900 pounds. That's a lot. Think about it. Everybody in the world threw out 900 pounds of garbage a year. A lot of garbage. All right, the function below, so they gave you the function, represents the average amount of waste each person will throw out each year after X years from the launch of the program. The community wants to examine the amount of waste each person will throw out 4 years after the launch of the program to 7 years after the launch of the program. So they want to know from year 4 to year 7. So what are we going to have to do here? What are some ideas? How are we going to get started? Who's talking? Is that Hannah? Are you talking? All right, say it a little bit louder. Okay, and then, okay, so Hannah says calculate for year 4 and calculate for year 7. That's probably a good idea to start. It says what was the minimum amount of waste generated in this interval? Alright, so let's do that. 900. Now there's 2 different ways we can do this. We can put in 4 right here and find the number. We can put in 7 right here and find the number. Anybody got a better idea how to use the calculator? Could I go to y equals and graph it and use my, what? Where can I find points? I'm just clearing this out while I'm talking. Where can I find points? When I'm graphing, where can I find points? Come on guys, help me out. What on this calculator is going to help me to find points? The table. So let's graph it. I've got inequalities on here. I'm just trying to get them out of here. Not what I wanted. So we had 900, and then we had in parentheses 0.98 raised to the x power. Now when I graph that, when I hit graph, calculators tell me it's spinning up here. It's trying to graph it. It's telling me it's graphed it right now. Again, not quite sure why some of you are sitting there not trying to do this with us, but that's okay. So where's my graph? I typed it in there, didn't I? I don't have any plots on. That's highlighted. So what's wrong? The window is wrong. What's my window? I'm on that standard window going from -10 to 10. Well, good Lord of mercy. How much am I starting with? 900 pounds, -10 to 10. Sure ain't going to get 900 pounds. Now, sometimes an easy way is to go to zoom. And if you go all the way down to 0, I went too far, 0 is zoom fit. Sometimes that's an easy way. That would be my next suggestion, go to zoom fit. Now, I could really care less what the graph looks like. What do I want to know? I want to know the table. Right here's my table. At 4, I had 830.13, and at 7, I had 781. Now, would I have got those same numbers by doing 900 times 0.98 raised to the, go back, delete, raised to the 4th power? What did I do wrong? I didn't raise it to the 4th power. 900 times 0.98 raised to the 4th. I did it again. I'll be done. Try again. Delete. Raised to the 4th power. There we go. Is that the same thing we got in the table? And then 900 parentheses 0.98 close parentheses to the 7th power? Same thing we got from the table? Alright, now let's go back to that equation. We have the equation. What's the minimum amount of waste generated in this interval? What are we going to do to those 2 things? Do what? Subtract them? Alright, so let's subtract them. let's just get a general idea. Let's just say 830 minus 781. I got 49. Is that what y'all got? If you have to be doing it, but okay. Alright, so let's see what they did. So they said, alright, the lower interval's 4, so they did 831. What did they do? So the minimum amount of waste generated in the interval 4 to 7 is approximately 831. Did we misunderstand their question? Okay, well, what did we say the answer was? 49. Did we misunderstand their question? Yeah. 49 is definitely not 831. You gotta be real careful about how they're asking the question here. It says, look at this solution. The given function represents exponential growth. So it's growing, right? Therefore, the lower bound, which is the 4, not the 7, the lower bound will represent the minimum number of users. So that's where this 831 comes in. So just be real careful about how they're asking that question. Alright, same idea. Let's see if we can get this one. College student launches a new social networking website. Wouldn't have been great to launch Facebook, all that money we would have got from that. Would have been really great. Alright, number of users increases at a rate of 27% per month. Pretty good. So it's increasing, so why did this 1.27 get in here? It's increasing and it's 1 plus 0.27, right? Now look at this question. The college students want to examine the number of users on the website from 3 months after the website's launch to 6 months. What's the maximum number of users? Now think about this. If it's increasing, right? Are you going to have more users at 3 months or more users at 6 months? 6 months. So would I want to do 3 months and 6 months? Think about the same thing that we did up here. What do you think we should do? Do the 6 months. Here's what they did. They did the 6 months, the minimum number, 6 months is 88. So if you put 6 in there, that's where your 88 is going to come from. So when you're going through these problems, be very careful. If you're doing an increase, and they wanted the maximum, you're going for the larger number. If you're going for something where it is decreasing, where does it say it? Reduce. So if it's decreasing, you want the smaller number. So be careful there. That's all the examples. Let me go back up. That they give us on this one. Let's go to the problem. There it is. And go through. So again, just like you did yesterday, these are much easier than some of the ones that we've done in class. Move this over. Yes, ma'am. Oh, I'm sorry. Yeah. 88. Oh, hold on. Oh, y'all gonna stop me. Hold on. Let me go back. Oh, I didn't hear you. Or I didn't see that you were raising your hand. I'm sorry. Let me go back. Okay, I've got batteries. Come up here. Let me go one down. Oh, girl. Then you need to be very careful come EMC time, because if there's something up, whoever's in there is not going to have extra time, so you make sure you keep it charged. Alright, so let me go back to this one. We were looking at, I'm sorry, I was just trying to rush through here so y'all have a lot of time on your homework. Let me go back there. Did I read the problem wrong? 23 to the 1.27. 23. Did they just write the number wrong? 36. Is that it?
Yeah.
Well, I believe, let's make sure. I sure didn't get 88, did y'all?
No.
So I think I was wrong then. But you get the idea of, well, we're putting in the six, they just got a mistake here. If we could email them and tell them their lesson has a mistake on it. Good, I'm glad y'all are, comment on lessons, let's do that. The next comment. Oh, that ain't gonna help me any, cause that's just gonna come to me. I'll have to see if there's some way I can send a comment another way. There's somebody there to do it. Alright, back to where we were here. Did I close it out? Okay, let me get back here. Interpret function in context. Your request cannot be processed. Alright, good. Alright, here we go. Alright, Sarah and Tricia are vacationing near a river. They would like to rent a canoe, a kayak, or one for each day. Or each for the day, sorry. The rental rates, which include an initial fee plus an hourly charge, are shown in the tables below. Now, this is a perfect example of a question they're going to give you on your test. Their questions, of course, they're going to have them not like this, but they're going to have them in multiple choice format. And the way the question is going to be worded, it's going to say something like, does a canoe rental cost more than a kayak rental? Or was the initial fee larger for the kayak rental or the canoe rental? That's the things that they're going to say. Or they could say, what's the difference in the initial fee from the canoe and the kayak? A lot of different ways they can ask it, but what have I taught you? Anytime you're given a table, what should you do? Put it in your calculator. So we're going to do this 2 times. We're going to do the canoe rental and the kayak rental. So I want everybody on that side, you 2 tables do the canoe rental, you 2 tables do the kayak rental. This row, y'all do whichever one you want. Okay? So the far right 2 tables are doing the canoe rentals. Y'all are going to give me an equation, so check with everybody so you should get the same equation. These far left 2 tables are doing the kayak rentals. You're doing an equation. Is this a linear, a quadratic, or an exponential? Alright, think about it. Does the rental go up and then go down, like a parabola? No, it does what? It increases at a constant rate, a set rate. So is it going to be a linear, a quadratic, or an exponential? Linear. It's going to be a linear. Alright, anybody got a canoe? Because you're doing, remember, L1, L2. That counts 4. So once you get it in, check with your neighbors, see if you got the same thing. You're putting that in L1, that in L2, and doing stat count 4. Tail, push your 2 down. Well, we're not graphing it, so it doesn't matter. Alright, so I'm hearing a lot of talking. Do I have a canoe rental cost or equation? A canoe rental equation? Canoe. Canoe. What y'all got? Guys, y'all can't tell me somebody doesn't know how to put this in L1 and this in L2 and do stack out 4. Y equals 6x plus 18. Okay, so what does that mean? The initial fee for renting a canoe is what? $18, and it costs how much for each day? Or hours, I mean. $6 for each hour. Right? Is that what you got?
Yeah.
Is that what you were doing? Alright. Alright, left side of the room. What's the kayak? Something plus 12. 4x plus 12? Okay, so how much does it cost initially to rent a kayak? $12, and how much per hour? $4. Alright, let's see what they're alright, the initial fee to rent a canoe? $18. The initial fee to rent a kayak? $12. Alright, which of the following describes the cost functions represented by the tables? Both are decreasing, both are increasing, and only one is increasing. Well, think about it. When you go buy something or rent something, does the cost go down or up? Up. So, Both are increasing. How else do I know that they're both increasing? The slopes are positive. Slopes are positive, so both are increasing. There's another way. Alright, if Sarah and Tricia rent one canoe and one kayak, not including the initial fee, what is the combined cost per hour? They rent one canoe, one kayak. What's the combined cost per hour? $10 an hour? Alright, let's see how we did. Booyah. Alright, next one. Alright, is that a linear, quadratic, or exponential? It is a quadratic, thank you. Does it have a maximum or a minimum? Maximum. Let's see. Before I go any further, what is its initial starting height? 3 what? 3 feet. Good. Alright, what is its, let me see how I can trick you here. At what time does it reach its maximum height? Oh, y'all getting pretty good. 2.5 seconds. Very good. What is its maximum height? 19 feet. Good. I don't have a clue what they're asking, but the trajectory of the projectile is symmetric about the line. Now let's go back. Here's some vocabulary. Remember, on every parabola, there's a vertical line right here that cuts it in half, right? And a vertical line always has the equation. All vertical lines have the equation. X equals. What is the x part of its vertex? 3.5. So remember, x is time right here. So x equals 2.5. Alright, at what time, plural, be careful, at what time, Christy? This is an English lesson. At what times is? What's wrong with that? It's going to be R. That's plural. I'm not a great English person, but I at least know that. There's something else we can comment on. I don't think they care, but anyway. Alright, so at what times are the height of the projectile at 15 feet above the ground? Alright, well, right here's 15 feet, right? So if I drew a line right through here, I crossed that red parabola twice, correct? What time is that right there? 1.25 and 3.75. Alright, let's try here. So you said this is the smaller one, 1.25 and 3.75. Alright, so submit. Yeah. Booyah. Okay, PTA, Northside High School sells burgers at the, I wish we had burgers, at the home basketball games to raise money for new uniforms. For each game, they purchase enough supplies to make 80 burgers. The hamburger patties cost $60, and the cheese slices cost $15, and the buns cost $25. Okay, they sell the burgers for $4 each, regardless of whether or not the customer asks for cheese. Well, how nice of them. The profit for the burger sales is grabbed. Let X represent, X is the number of burgers they sold. Y is their cost. I mean, I have not a clue what they're asking, but how many burgers do they have to sell to break even? How do you know it's 25? Because that's where it crosses the 0 point on the cost, right? So they got to sell $25 at least to make back all this money they had to spend, right? I don't know what they're going to have to do. Alright, over which interval is the PTA making a profit to go towards the new uniform? Alright, now, would you agree that the profit is this part above this y equals 0 line? Okay, and this would be not a profit, correct? Alright, so now look at this right here. Why does this one have a parentheses and this one have a bracket? Oh, well, okay. They're asking to make a profit, right? So you just said it's the one above the line, correct? Okay, so at this point, y'all said that's the break-even point. What is that point right there? Like if I said, tell me that point, what is it? What's that XY point? 0.25. So think about it. At 0, does 0 represent a profit? No, it doesn't represent a profit, does it? So, going back to here, any idea why one's a parentheses and one's a bracket? Think about the idea of a solid circle and a dotted line, or a solid line, or an open circle. Is a point on a dotted line included in the solution? Let me say that again, because this is important. Is a point on a dotted line included in a solution? No, it is not. So at 0.25, is that a profit? Is $0 profit? No, they didn't make it. So that at 0.25, if they sell 25, have they made a profit? No, they're at the break-even point. So over which interval is the PTA making a profit? So if they sell 25 hamburgers, have they made a profit? No, so they got to sell more than 25. That's like a dotted line right there. That's why it has a parenthesis. Now, what do you think we're going to put here? What does it show us on the graph? This is kind of tricky, I think. Because really, they could go on and on forever and make a profit, right? Well, what do you think? Think we've messed up? You think we should put the, I don't know, what number should we put in here? And I'm not joking. I don't know what we should put in here. Because to me, that's kind of a trick question. I mean, because the graph only goes to, what do they count, by 5? 65, 60, 65. They're only going to 70 on this graph, but that red line only goes to, what is that, 30, 35, 40, I don't know, 42 and a half? What do y'all think? What should we put? I don't have any idea, honestly. What should we put right here? Because there's a trick in there. I don't have her. I have her first part. Alright, sorry. What do you think we should put in there? Come on, we gotta get something. What are you gonna put? Now put the number that's on here. I have no idea. Y'all not saying anything, so I'm just gonna guess. I have no idea. We knew it was 70, but I don't know. Maybe we'll put 43. No, it won't let me do it. I got the explanation. I forgot about that. 80. Oh! 80 burgers. I didn't read the problems. Everybody see where that came from? 80. They say they can only make 80 burgers. Well, duh. If they can only make 80 burgers, that's the most they can make. There's no problem. Yeah, the answer was right there in the question. So if you get this problem, remember that. Alright, let's go to the next one. I got it. Alright. Okay, two initial things. We're comparing two graphs. So Daniel has two accounts. He withdraws a certain amount. Withdrawal means it's going down, okay? The account balances over time are shown in the graph. So how much did he put into account 1 to start out with? $20. How much did he put in account 2 to start out with? Careful. Not 18. It's in hundreds of dollars. 2,000 and 1,800, 1,800. All right, so the initial balance of account 1 was 2,000. Notice they put 20 on there to trick you. Do we agree 2,000? All right. Balance 2. Those of you not paying attention, 1,800. Which account has a non-zero? What does that mean? Has money in it. Has a non-zero balance longer than the other account, and by how many months? Which one runs out of money quicker? 1 or 2? 2. How else would I know that? It has a steeper slope. So 2 runs out of money quicker, but by how much? That's at 16 and that's at 12. So by how many months? Be careful. Which account has a non-zero balance longer? Does 1 have a balance longer, or does 2? 1 does, because it loses money slower, and it's by 4 months, right?
Yeah.
Oh, are we going to get it? Yeah. Alright. Okay. Quadratic, linear, or exponential? One key right here. Quadratic and quadratic. We worked on these. This is the initial velocity. We did projectile motions for 2 days, people. A golf ball hit off the ground with initial velocity of 88 feet. Initial velocity is v. So 88 goes right here. Create a function to represent this situation. So we're putting 88 right here. Well, if it's hit off the ground, where does it start? 0. If it's hit off the ground, it's at 0 feet. So negative 16t squared plus 88t plus 0. Alright, use the function to complete the sentences below. Express each answer as a decimal and round to the nearest hundredth. So we've got a lot of things we've got to be careful of. Do we need to graph that? Hint, yes. The golf ball's height is increasing on the interval. Well, we better graph it. Do a little, I can't do a split screen with a calculator. So, alright, so let's go to y equals, clear this one out. So negative 16t squared again. If I'm typing, you should be typing. Negative 16x squared plus 88x. Do I need a plus 0? I don't need it. Does it make it wrong if I put it in there? No, not really. Alright, so I got some of you not doing it. Now, remember I did that zoom 0 last time because we were dealing with 900? If we do zoom 6, that standard window negative 10 to 10, do you think that's going to help us out right here? Well, it starts out at 0 feet, doesn't it? But it is going up at 88. I'm just going to hit zoom 6 just to see kind of what it looks like. Work my way out from there. It's starting out right here and it's coming down over here, so I need to see more of the y value, right? So I'm going to go to y max. So window, what's a guess? Y max. Remember, we're going up 88 feet per second. How high? What do you think, Reese?
Well, I don't know.
We could do the zoom fit. I'm just trying to get, I'm giving people different options. Everybody hear what Reese said? Why don't we just do zoom 0? If I do zoom 0, would that work too? Yeah, can we see the top of it? We probably still need to see more of it, but you could do this as long as you can see where it starts, as long as you can find the maximum and you can see where it intersects, you're okay. Let me go back to here so I can make sure everybody understands what I'm doing here. So if you're on the zoom standard, does everybody understand I need to do my Y max? What am I going to do on Y max to? How high do you think that golf ball's going to go? How many feet? 100 feet high? Okay. Do we want to count by 1? Count by 10. I'm just guessing. But just like Reed said, we most certainly can do the zoom fit. Not 100 feet. 200? Alright, so we'll try 200. Still count by 10. Alright, good. So we can see it now. Alright, so here's where the golf ball's being hit. There's the maximum. Here's where it hits the ground. Let's go back and see what it asked us. It says, the golf ball's height is increasing on the interval. Now notice, 0 has a parenthesis because it is it increasing when it's sitting on the ground? No, it's not increasing. It's sitting there. Why does it have a parenthesis right here? What happens, think about it, when the ball's going up, it reaches its maximum height. Is it increasing right there? No, it's not doing anything. But we need to find that maximum. So when we, how do we find the maximum? Second trace, so second count, max, so number 4. And then we put our, remember it asked us, alright, go to the left of it. So we move our cursor up there again. You should be doing this with us. Move it to the left, and we hit enter, and it says, okay, move me to the right, and I hit enter. And y'all think I'm stupid when you just pick up your calculator and act like you're doing something and you're not. That's okay. Who's going to be the stupid one when that test comes? Put our left left bound, our right bound, and then some of them would say, oh, it's 3 and 118, and I'm gonna say no. What do you have to do? You gotta hit guess. You gotta hit enter one more time. Alright, remember, it said decimals to the nearest hundred. So what am I looking at? 2.75 or 121? 2.7, I want to feel like I'm yelling, and then I'm not yelling. Are we looking at the X or the Y? The golf ball height or the time? We're looking at the golf ball height is increasing on the interval, so it's increasing as a function of time, right? So we're looking at that X value. So would you agree to the nearest hundredth? The hundredth is that second place, but that 0 doesn't make it go up. So that would be 2.75? 2.75. Alright, and decreasing on the interval, well, where does it start to decrease? Hayden and Chris, simply pay attention. 2.75. Okay, remember, this is not included because it's got that parenthesis. It doesn't have the bracket. Now, this is going to be where it hits. But I need to find that point right there. A couple different ways. I know it's in between 1, 2, 3, 4, 5, and 6. It's in between 5 and 6. How do I find that intersection point? What did we do? A couple different ways. If I go to second calculate, there's two things on here I can do. Any ideas? 5 intersect? Well, what am I going to intersect it with? Because the only thing I have in here is this. I remember you got to put y2 in to be 0. Now we can intersect. Because we're intersecting it with that y-axis. The second count, see, notice my red line's in there now. I want to move my cursor over to that intersection point. Oops, and keep going. Okay, and hit enter. And what is that one? 5.5? Alright, so we've got 5.5. 5.5. Alright, maximum height of the golf ball. We just did that one. What was the height? 121, wasn't it? Alright, submit. Alright. Call Me, a pay-as-you-go cell phone company. Has a very popular cell phone plan called the Cell Plan. I think that's creative. Alright, the customer pays $25 for 250 anytime, anywhere minutes, and each minute is the same cost, no matter what the customer's location. You get $25, no matter what. But the x-axis represents the number of minutes the customers use. So here's the number of minutes they cost. The y is the amount of money they have left in their account. What does the y-intercept right there represent? The customers use no minutes. Customers pause for 250 minutes. The customer has $0 in their account. The customer has $25 in their account. The y-intercept. Did you hear that? Is that what I hear? Am I getting right? Okay. I'm just saying, are we going with D? No, calculating tricky. Alright, actually it's getting into the time where I want you to start, let me do this in just in case something you want to do. Alright, Dennis Wilderness Troops Con Girl Scouts selling s'mores to raise money for new camping equipment. They have enough supplies. Oh, let's not get tricky again. How many can they make? 50 s'mores. Graham crackers cost $8. Marshmallows cost $5. Chocolate bars cost $7. They sell the s'mores for $2 each. The earnings for the s'mores sales is graphed below. Alright, let X represent the number of s'mores sold. Alright, so here's the number of s'mores sold. And Y represent the amount of earnings raised for new camping equipment. Determine which interval represents the wilderness troop making a profit and draw a line segment on the ray to show the interval. Okay, well, making a profit. What do you think? We talked about profits always above, right? Does it include this number? If they sell 10 s'mores, have they made a profit? No, they've just done what? Broken even. Now, how many s'mores can they sell? 50. I don't wanna get caught on that, so let's see. They say draw a line segment, so let's do a line segment. Do I want an open point or a closed point right here? Does it include 10 s'mores? We just talked about it, doesn't include 10 s'mores, so I want an open point right there, cause it doesn't include 10. I want another point at 50 there, right? And I want a line segment from here to here. Well, they only sell they only sell 50 s'mores there, right? 50 s'mores. But I wanna make sure that that's an open point. I don't know that it included that open point. I'm gonna go back over here and say, put me an open point right there. Does that look better? I don't know. Yay! Yay! Ooh, another one. Projectile shot upward its distance above the ground in feet and t seconds. So t is the x, y, or s of t is the feet above the ground. Use a number line to represent the interval on which the projectile is descending. This is an easy one. Graph that sucker right there. Put that in your calculator. Put that in your calculator. Negative 4t squared plus 24t. Negative 4t squared, I'm gonna clear that one out. Negative 4t squared plus 24t. Or x, not t. Negative 4t squared plus 24t. I have no idea, I'm just gonna go Z6, just to get an idea of where I'm at. Definitely need to see more of the y. So I just did Z6. I'm gonna go back and increase my y. So I'm gonna go to my window and go to, I have no idea. I'm just gonna go to, I'll go to 100 just to see. Whatever. Just guessing. I can see it now, which is good. Alright, Rich, you do Z0, did it look any different? Oh, okay. It's kind of real spread out? Okay. Alright, so it said, where is it descending? Descending. So we gotta decide. It descends from this point to this point, correct? Alright, well that point looks like it crosses at a whole number, right? 1, 2, 3, 4, 5, 6. I'm gonna look at my table and see if there's a 0 at 6. And there is, so I know that. But I gotta find that point, so I gotta find the maximum, so I'm gonna go second, calc, maximum. Put that clicker up there at the left part of it, and again, some of you are not doing what you need to do. How many times have I said that today? Going to the left, going to the right, and hitting enter. Am I looking at 3 or at 36? I did 6 right here, so am I looking at 3 or 36? 3. Now, is it descending at 3? That's at the highest point, right? Is it descending at 6? Technically, according to the graph it is, but once it hits the ground, it's going further. No. So, from 3 to 6, so we said, should it be a closed or an open point at 3? At that highest point, is it descending? No, it's kind of suspended in air, right? So it should be an open point at 3. Alright, what about 6? Should it be open or closed? Open or closed? What's it doing at 6? It hit the ground, right? Is it going anywhere? No, so it just hit the ground. So it should be an open point. And just say draw a, come on. I thought I did. Oh, and then make it open? Oh. So much better. Alright, let me do my line segment. So there's my line segment. Now I want an open point here. So are we good with that? Because that's where it reaches its highest point. So it's not doing anything there. Not descending once it hits the ground. Let's see. Yay! Ooh, this is a good one. The atmospheric pressure in millibars at a given altitude and feet above sea level can be approximated by the function. Big thing here. Alright, for values of x at 0 to 32,800, what does the y-intercept represent? Well, the y-intercept is the what? Starting point, right? Which one of these is the y-intercept? This is the y-intercept right here. So which one do you think? What do we think? C? Altitude at x and feet above sea level. Be careful. Be careful. Alright, last one. A company created a new product. They're research and development. Y'all ever heard the term R&D? The R&D team? Research and development team came up with a graph of the function below, which estimates the daily profit, P of x, on this product at different prices in x dollars. Alright, now think about it. Here's the number they made. Here's the profit. Right? The potential profit, P of x, at different prices. Where's the maximum profit? It's up here, right? What is the maximum amount of profit? 128 at the cost of what? $4. So what they're showing you is if I charge $4 for something, the maximum I can make is 128. If I charge $12, you think more people are going to buy something at $12 than at $4? It kind of depends on what it is. But, alright, the new product should be priced at what? So what do we want to price it at? We want to price it where we get the most money, right? Which is where? $4? Okay. In order to maximize, there's a hint, maximize. What is the maximum possible daily profit of this new product? 128. I'm at 128. Okay. That it? Nope. In which price range will the product potentially not earn a daily profit? Not earn a daily profit. Let's see what our choices are. 0 to 4, 4 to 8, 8 to 12, or 12 to 16. 0 to 4, 4 to 8, what was the other one? 8 to 12, or 12 to 16. 12 to 16? You ready? Why 12 to 16? Because it's down below the profit, down below 0. Alright, now y'all are at the end. Please take your time. Don't go through and just guess at these. You can do these. Take your time. Remember, you just got the 10 questions, and some of you need to go back and redo yesterday's or all of the other ones before. Remember, they're open till May 31st.